Hello there and welcome to B3D. In this video I will be showing you how to rotate an object 360 degrees in any view. This exercise will involve using angle dimensions to control the rotation in plan and elevation view. The geometry that's going to be used here will be a cylinder-shaped geometry. Of course, the geometry and the concept can always be changed to fit the user's needs. So here's a little breakdown of what each family's role is. Family C will contain the geometry and will have the ability to be rotated 360 degrees in one view. Family B will contain Family C and it will have the ability to be rotated in all views. Family A will contain Family B, and you can create as much instances of Family B as you need to complete a model concept. It will also have the ability to control the height of each instance of Family B. So let's get started with Family C. For Family C, let's open up a generic face-based model template. As you can see here, I have one opened already. First thing we'll do is we'll save the family. Go ahead and save as, and let's name it C. The second thing we'll do is we'll open up the front view. Let's go ahead and open it up. And we'll move the reference level away from the reference plane. The reason why is because we'll be using the reference plane to align a lock later on, and we wouldn't want to accidentally hit the reference level when we're aligning and locking. So let's go ahead, select the reference level, and select the move tool. And let's just move it somewhere off to the side here. So now that the reference level is not in our way anymore, let's go on to the next step. The next step is to draw a reference line where the two reference plane intersect, which will be here. So let's go ahead and draw a reference line and select the intersection point to be our starting point. And let's go ahead and stretch it 1 feet at 45 degrees. So here it is, I have it 1 feet at 45 degrees. Next thing we'll do is we'll align and lock this endpoint of the reference line to the reference planes. So let's go ahead and activate our align and lock tool, which is here. So let's go ahead and select the reference plane first and select the endpoint. And go ahead and click on the lock tool. So we'll repeat the same step, except we'll select this reference plane this time. And we'll select the endpoint again. And let's lock it again. So then the next step is to draw another reference line perpendicular to the one we just drew. So let's go ahead and create another reference line. For this, I like to just start at the endpoint and just drag it off about 1 inch. And then what I like to do next is to click on the endpoint I started with and just drag it another inch over. So it's about 1 inch on each side. So our next step is to create an equal dimension between these two endpoints to make sure that the first reference line here stays in the center. So let's go ahead and create an equal dimension. Go ahead and click on the align dimension tool, and first thing you want to do is select the first reference line and then select the two endpoints, the second reference line. So as you can see, 2 dimensions was created. Can't quite see it here. It's because of the scale. Let's change the scale from 1/2 inch to, let's say, 1.5 inch. Let's go ahead and zoom back in. So you can see here the 2 dimensions came up. Let's go ahead and select the dimension and hit the EQ button. That'll make sure that the dimensions stays equal to each other. Next thing is we'll create another align dimension, but this time instead of selecting the 2 endpoints, we'll just select one. So let's go ahead and select the first reference line and select one endpoint. Let's go ahead and select that dimension that we just created, and let's give it a label. Let's call the parameter radius. Go ahead and hit OK. So now that we have our radius set up, it's time for the next step. The next step is to create an angular dimension between the 2 reference lines to make sure they stay equal to each other. So let's go ahead and create an angular dimension. Select the first reference line and the second reference line. And here it comes up to 90 degrees, and that's what we want. We want these 2 lines, these 2 reference lines, to always be perpendicular to each other. So with that created, let's go ahead and lock the dimension in. So our next step is to create another reference line, but this time we'll be drawing the reference line at the other endpoint. And to do this, I just like to copy and paste basically. So go ahead and select the second reference line and press CC. That's a shortcut for the copy command. So once the copy command is activated, let's set the starting point at the center, and let's set the endpoint at the endpoint. So with that done, as you can see here, the 2-inch dimension came over. Go ahead and select the dimension and delete it. So the same thing as we did down here, let's create the dimensions again. Label as radius, and we'll add an angle dimension here, and we'll lock it. So once you have that done, the next step is to create an angular dimension from the vertical reference plane to the first reference line, and that's going to control the rotation of the geometry we'll be creating in a bit. So go ahead and click on angular dimension if it's not activated already. So once you have activated, go ahead and click on the reference plane and click on the first reference line. And here it comes to 45 degrees. Let's select the angle dimension and give it a label. We'll call this dimension angle. And hit OK. And then the next step is to create an align dimension from the second reference line to the third reference line over here. And that's going to dictate the length of the object we'll be creating in a bit. So go ahead, activate your align dimension tool, click on the second reference line and the third reference line, and let's bring out the dimension, and click on the dimension and give it a label. Let's label the parameter, let's call it length. Go ahead and hit OK. So our next step is to flex the family. By flexing the family, I'm talking about changing the parameter values to see if the family changes with the dimensions. The reason for this is to make sure that the family can flex on a low value and a high value, just in case the values get changed later on and it might break the family. So this is where we test it out to make sure that our concept works at this point. So here I have the family types window already opened, and I'll shrink it down so we can see when we're changing the values. So when flexing the family, I like to use a big value and a small value and change it a couple times around, just to see if the family flexes well when it gets bigger and when it gets smaller and in between. So I'll go ahead and skip it a bit and zoom out a bit so we can see what's going on. I'll also hide the dimensions, since these are just reference lines and the dimensions are kind of clogging up the view. So here, let's go to visibility graphics and let's hide the dimensions for now. To go to visibility graphics, the default command is VV, so go ahead and hit that. And let's change the model categories and let's go to annotation categories. Here the dimensions checkbox is checked. Let's uncheck it and hit OK. And for now the temporarily hidden, and if we want to turn it back on, all we have to do is check the box again and it'll come back on. But for now, let's go back to our family types window and let's flex the family. The radius, let's change it from 1 inch to 12 inches. This is our radius here, and it seems like it's working out. So it's still staying equal on both sides, and the first reference line is still in the center. Let's shrink it down to 3 inches. Let's bring it up to 6 inches. For the length, let's change it from 1 feet to 10 feet. Oh, that's 10 inches. 10 feet. There we go. It looks like it went off screen, so I'll close the box and zoom back out. So it looks like it's going okay. Let's change it from 10 feet to 4 feet. Oh, 4 inches again. 4 feet. And let's change it to 7 feet. 7 inches again. 7 feet. There we go. So now that now that you can see that the radius and length, they stretch okay. Let's go ahead and change the angle. So let's go from 45 to 0. Seems like it's going okay. It's back at 0 degrees. Let's go to 75 degrees. Let's go to 90 degrees. Let's go to 135. Let's go to 180. Let's go to 225. Let's go to 270. Let's go to 315. go to 360. So now that we know that it can be rotated 360 degrees, let's change the values back to its original value. So let's change the angle back to 45. Let's change the length back to 1 feet. And let's change the radius back to 1 inch. Go ahead and hit OK. And let's zoom back into the reference lines. So now that we see that it flexes okay, let's go ahead and turn the dimensions back on. So let's open up the visibility graphics by hitting VV again. Let's go to annotation categories and check the dimensions checkbox. Go ahead and click OK, and there we have our dimensions again. So now that we see that the reference lines can be rotated, let's add in our geometry. The geometry that's going to be used here will be sweep. So let's go ahead and create a sweep. Yes, I would like to save the project. So go ahead and click on sketch path, and the path will just cover a part of the first reference line. You don't have to cover it all the way, just a portion of it. So our next step, once we have our sketch line drawn, is to align and lock the sketch line. So let's go ahead and hit the align tool. First thing we'll align is the sketch line to the first reference line. So go ahead and click on the first reference line and go ahead and click on the sketch line, and let's lock that in. Now let's lock the endpoints at the second reference line and third reference line. So let's select the second reference line and select the endpoint of the sketch line. Go ahead and lock it in, and we'll repeat the same step on the third reference line. So let's go ahead and select it, select the endpoint, and lock it. So that pretty much covers our sketch. Go ahead and hit finish, and it's time to draw in our profile. So go ahead and click on edit profile, and here's a window box. It's letting us know which view we want to draw a profile in. So let's go ahead and select the 3D view and go ahead and click open view. So right now we're in a 3D view. Let's zoom in to the red dot here. And since the thick lines is on, I'm going to turn the thick lines off for this case. The shortcut here for changing thick lines to thin lines is TL. So if you press TL, it'll turn thick lines into thin lines. So now that we're in a 3D view, this is where our profile is going to start. So here we see two reference planes and a red dot. So let's go ahead and draw a circle. And we'll have the circle start at the red dot and just stretch it out at any dimension you want. The next thing we'll do is we'll create a radial dimension for the circle we just created, and we'll just draw it out there. Let's go ahead, link up the dimension to radius. So that covers our profile, and go ahead and hit finish again, and that pretty much covers our geometry for family C. So now that we have our geometry created, let's go ahead and go back to front view. Go ahead and open it. And next thing we'll do is, again, we'll test the family out by flexing it. Since we know that the Revit lines can be rotated, let's see if the sweep will follow it also. So here I have the family types open, and let's go ahead and start flexing. Let's change the radius to 2 feet. And here, since the dimensions are starting to get in the way again, I'm going to go ahead and hide them again. And I'll also turn the view from wireframe view to shaded. This will make sure that I'll see the geometry flexing instead of just seeing lines. So let's go ahead and open up the family types window again. And let's change the radius to, let's say, 8 inches. Let's go ahead and change the length to 14 feet. Here it went off screen again, so I'll go ahead and zoom back out. So it's looking good. Let's change it to 1 feet. Let's change it to 6 feet. So it's looking good so far. And let's test the angle. Let's go to 0. Let's go to 45. Let's go to 90. Let's go to 135. Let's go to 180. Let's go to 225. Let's go to 270. Let's go to 315. Let's go to 360. Let's go to 0. So now that the sweep follows the reference lines when it rotates around, then that's pretty much family C. So next thing we'll do is we'll go ahead and close out of that. Next thing we'll do is we'll add a material parameter to the sweep, just so we can change the material of the geometry. So go ahead and click on the sweep, and in the properties window, let's go ahead and link up the material to a parameter. So go ahead and enter parameter, and let's call it finish. Go ahead and click OK. And of course, let's test out the material parameter, see if it works. So let's go ahead and open up the family types window. And here, let's select the finish parameter, and let's change the material. Go ahead and X out the material editor, and let's change it to glass. Go ahead and hit OK, hit apply, and here the sweep changes. But let's try a different material just in case. Let's go to default. Let's see what happens. So it's at default right now, and it works. And this pretty much covers family C. In family C, we were able to rotate the geometry 360 degrees in one view, and we were able to change the finish. So that pretty much wraps it up for family C. Let's go ahead and exit out the window, and let's change the angle to 45 degrees. Let's change the length back to 1 feet. Let's change the radius to 3 inches. And this is just to prepare us when we nest in family C into family B. So go ahead and save the family, and let's move on to family B. For family B, let's go ahead and open up a new generic model template. So let's go ahead and open up a new family and select generic model. First thing we'll do is we'll save the family, and let's name it B. Go ahead and save it. And family B is pretty similar to family C, the way they're set up. So let's go ahead and open up the reference level. It's open up on default, but if you don't have it open, go ahead and open it up. So first thing we do is we'll draw a reference line at the intersection of where the reference planes meet up. So let's go ahead and draw a reference line there, right at the intersection. And let's stretch it out at 12 inches at 45 degrees. Next thing we do is we'll align a lot the endpoint to the reference planes. So let's go ahead and hit the align tool. Select the reference plane and the endpoint, and repeat it for the other reference plane. Next thing we'll do is we'll draw another reference line perpendicular to the one we just drew. So let's go ahead and draw another reference line. Let's start it at the endpoint of the first one. Let's stretch it out, say 2 inches here. And go ahead and select the reference line again. And let's drag the endpoint here. And let's drag it out 2 more inches. So a total of 4 inches. Next thing we do is we'll create an equal dimension between the 2 endpoints of the second reference line. So let's go ahead and do that. So with the line dimension tool selected, let's go ahead and select the first reference line and the 2 endpoints of the second reference line. So you can see here 2 dimensions got created, and let's click on the EQ button. Let's repeat this same step, but this time select 1 endpoint. So now that we have this dimension created, go ahead and select it. Let's give it a label. We'll call this host radius. Let's change the group parameter from dimensions to constraints. And let's change it from a type parameter to an instance parameter. So next thing we do is we'll draw an angular dimensions in between the 2 reference lines. So let's go ahead and activate the angular dimension tool and go ahead and select the 2 reference lines. So here it comes out to 90 degrees, and that's what we want. Go ahead and lock it in. And so we'll be drawing another reference lines, and we'll basically be repeating the same steps over. But this time we'll be drawing it at the other endpoint of the reference line. So an easy way to do this is to click on the second reference line that we created and hit CC. That's a shortcut for the copy command. And since we have the reference line selected, the copy command gets activated. So let's set the starting point to the midpoint of the reference line. Go ahead and click on it. And for the extension, let's go to the endpoint of the first reference line. Go ahead and just click into open space. And you can see here 4 inches came over when we copied the reference line over. Go ahead and select it and delete it. So basically we'll be repeating the same dimensions here and here. So let's go ahead and repeat the equal dimension. Go ahead and select the first reference line and the 2 endpoints. Hit the EQ button and draw another dimension to 1 point. Select the dimension and label it as host radius. Next thing to do is to draw an angular dimension between these 2 reference lines to make sure they stay perpendicular to each other. Let's go ahead and select this first reference line and the third one, and it comes out to 90 degrees. And let's go ahead and lock it. So our next step is to create an angular dimension from the horizontal reference plane to the first reference line. So with the angular dimension still selected, let's go ahead and select the reference plane center, front, back, and the first reference line. And here we have 45 degrees. Let's go ahead and select the angle and give it a parameter name. And let's name the parameter. Let's name the parameter actual angle top. Let's change the group parameter from dimensions to constraints. And let's change it to an instance parameter. And let's hit OK. And it flew off on me somewhere. Oh, there it is, down here. And it's okay if it flies off on you too. It's still reading as 45 degrees from this reference plane to this reference line, but it just moved over here, and I can't explain why it does that. The next thing you do is to draw a line dimension from the second reference line to the third reference line. So with the dimension to the align dimension tool activated, go ahead and click on the second reference line to the third reference line. And let's give that dimension a parameter name also. Let's call it host radius. Let's change the group parameter to constraints. And let's hit OK. Oh, not host radius, host length. Let's go with the parameter name host length. Go ahead and hit OK. So the next step is to open up the family types window. And here, I made an error here. Let's change the host radius. Go ahead and click on host radius. Hit modify. Let's change it back to type for now. So let's set the formula for the host radius. Let's change that to 1 inch. And this will make sure that the host radius stays at 1 inch. And let's change the formula for host length to 1 feet. And again, this will make sure that the host length will always be at 1 feet. So now that we have the basic setup, let's go ahead and test out the family by flexing it. I'm going to go ahead and hit OK and hide the dimensions again by hitting the visibility graphics window. So the shortcut for the visibility graphics is VB. I'll go ahead and go to annotation categories, hit uncheck the dimensions box, and hit OK. So now they're temporarily hidden for now. And I'm going to go ahead and open up the family types again. And since here we only have an angle to stretch around, that's the only angle we'll be testing here. So here it's at 45 degrees. So change it to 0. And as you can see, it went back down 0. Let's change it to 45. Let's change it to 90. Let's change it to 135. Let's change it to 180. Let's change it to 225. Let's go to 270. Let's go to 315. Let's go to 360. And let's go back to 0. So again, now that we know that the family can rotate 360 degrees, let's bring it back to 45 degrees for now. Go ahead and hit OK. Our next step is to open up the family types window again, and this time we'll add another parameter. Go ahead and click on add parameter. Let's call this parameter angle top. Let's set the type of parameter to angle, and let's set it to be instance parameter. So in the formula of actual angle top, let's go in there and let's add a formula in there. And the formula goes like this: if left parentheses 1 equals 1, comma, angle top plus 180, comma, 0, right parentheses. So let's take a look at this formula that we put in here. The reason why I put if 1 equals 1 is because I want this parameter here to be locked. I want the value to be locked, and I want the parameter angle top to dictate this parameter value up here. The reason why is because, well, it's at 180 right now, but the angle top is at 0. So when we draw our sweep is going to start from the center point here and run this way to our left. But when we nest in family C will be placed on this face of the sweep, and it will be extruding to our right. So the logic is that since angle top is at 0, it'll make it look like family C is at 0 degrees. And the sweep that we're going to be drawing in a bit, the sweep will actually not be visible. We'll actually turn the visibility off. And the sweep is basically going to act as a host to place in family C. So in a sense, we're creating an angle parameter to flip family C in plan view and elevation view. And since family C can already be rotated in one view, this family holds the second angle control for family C to rotate. And it'll make much more sense once we actually draw it out. but I just want to give you a heads up of what's going to happen. So since we have this family parameter added here, let's go ahead and flex it. So it's at 0. Let's change it to 45. Let's change it to 90. Let's change it to 135. Let's change it to 180. Let's change it to 215. Let's go to 270. Let's go to 315. And let's change it to 360. So as you can see here, changing to 360 broke the family, which is something that I find strange and funny at the same time. So let's go ahead and hit cancel, and let's try to see what's going on. So the parameter angle top, it's not actually an angle parameter placed in the drawing. Likewise, as we place an angle for actual angle top into the drawing, and we labeled it actual angle top. So the problem lies at actual angle top, and here the value comes out to 540 degrees. So if we take 540 degrees and we take away 360 degrees, and then it ends up to be 180 degrees, which I find strange, because since 360 is a full rotation of a circle, it should, in theory, be able to flex to 540 degrees. But let's go ahead and take away 360 degrees. And as you can see, it goes back to 180. And if you hit apply, it flexes fine. But if we add 360 degrees, it goes back to 540, and it breaks the family. And if we add another 360 degrees, which is another full rotation, which is another way of just saying 180 degrees, it breaks the family also. So if we set the angle to 720, the angle comes up to 900 degrees. And if we hit apply, again it breaks the family. And if we add another 360 degrees, another full circle rotation, comes up to 1080. And again, it breaks the family. But if we just bring it back to 180 degrees again it's fine. So I can't explain why it's doing that, but I can advise you that if you want the value of actual angle top to be 360 degrees, no, not 360, but 180. No, not 180. Yeah, it would be 360. What am I saying? I would just suggest you to leave it at 0, since it is the same value as 180. So let's go ahead and leave angle top at 45 degrees for now. Go ahead and hit apply and hit OK. So now that we have the rotation going, let's add in our geometry. So let's go ahead and create a sweep. And let's save the project. And let's go ahead and sketch in our path. So again, let's sketch the path line, just a line that hovers over the first reference line. It doesn't have to cover it all the way, it just has to cover part of it. Let's go ahead and hit the align tool, and let's align the sketch line to the first reference line. So go ahead and click on the first reference line and click on the sketch line. And next we'll align and lock the endpoints to the second and third reference line. So go ahead and select the third reference line. Click on the endpoint. Let's lock it in. And let's head on the second reference line. Select the endpoint and lock that in. Go ahead and hit finish and hit edit profile. And the view window comes up. Let's select the 3D view, and that's where we're going to be drawing in our profile. So let's go ahead and zoom into this red dot here, and let's rotate it to our right. So when I rotate, I hold down the shift key and I hold the right click button, and I start moving towards my left, which will rotate the view to the right. So since we rotated the view, let's go ahead and zoom in a bit, and let's draw a circle. Go ahead and click on the circle and start the circle drawing at the red dot. Go ahead and click on it and stretch it out. And it doesn't matter what the dimension is. Let's go ahead and add a radius dimension to it. And we'll label this host radius. Go ahead and hit finish and hit finish again, and that'll take care of it. Let's go ahead and go to plan view, and let's flex the family again. So again, let's change the value to the angle value to 0. Let's change it to 45. Let's change it to 90. Let's change it to 135. Let's change it to 180. Let's change it to 215. Let's change it to 270. Let's change it to 315. And let's change it to 360. And again, it breaks the family. So to test 360 out, I'll just leave it back at 0. And since the sweep follows with the reference lines, we can conclude that it flexes fine. So the next thing to do is to click on the sweep, and let's turn the visibility off. And again, the purpose of the sweep is to act as a host for family C, which we'll be nesting in right now. So I still have family C open. If you don't have it open, go ahead and open it up. And go ahead and click on load into project. And this will load in family C. So let's go ahead and open up our family types window again. And let's change the angle top to 45 degrees. So when we're placing in family C, we'll be placing a 3D view, but we'll be placing it on this face of the sweep here. So when we place in family C, we can verify in plan view that it gets placed on this face of the sweep. So let's go ahead and go to 3D view. Go ahead and open it up. And let's zoom in on the sweep for a minute. And let's go ahead and activate family C. So in the project browser window, go ahead and expand families, expand generic models, expand C, and let's click on C. Let's right click it, and we'll click on create instance. So let's go ahead and zoom in and rotate it up just a bit, and go ahead and hover over the face of the sweep. And since the circumference of the face is highlighted in blue, that means when we're going to place in family C, that's going to be the face we'll place it on. Let's go ahead and hit spacebar one time. That'll rotate the axis of family C. And once you hit space once, go ahead and click on the face of the sweep, and that'll place in family C. Let's go ahead and go to front view. Let's open that up. Let's go to the properties of family C, and here it's at 0 degrees. Let's change it to 45 degrees to make sure that it is rotating an elevation view. Go ahead and hit apply, and here it is. And that's just to verify it. You can go ahead and hit cancel and hit undo. No, let's leave it. Let's leave it the way it is for now. So since we placed in family C, let's go ahead and align and lock it to the first reference line. So let's go ahead and go up here, and let's close all views. Let's go ahead and press WT. That's the shortcut to tile the windows. And since I have family C open, I'll minimize it for now. So let's open up the floor plan also, and let's hit WT again. So first thing we'll do is we'll go to our floor plan, and we'll zoom in, and we'll align and lock family C to the first reference line. So let's go ahead and hit the align tool, select the first reference line, and select the reference plane that shows up when you hover over family C. Go ahead and click on it, and let's lock it in. Next thing we'll do is we'll go to the front view. Go ahead and click on that, and let's click on the reference level and move it. Let's move it away from the reference plane, just in case we accidentally hit it when we align and lock. So again, here in the front view, we want to align and lock family C to the first reference line. And the reason why I asked you to do the window tile mode is so you can go ahead and go to your floor plan and click on the first reference line. And in here, if you click back on the front view, it's being highlighted here also. So if you select it, if you select the first reference line in plan view, it'll be shown in the front view also. So here you have a sense of where it is, and go ahead and click in open space, and let's hit the align and lock tool again. So go ahead and select the first reference line, and let's click on family C. So as you can see here, this is the reference plane that comes up when we hover over family C, and that's what we want to align it to. So let's go ahead and click on that and lock it in. So now that we have family C aligned and locked, let's go ahead and create a couple of parameters before we test out the family again. So go ahead and open up the family types window, let's create a parameter. We'll call it finish. We'll change the parameter type to material, and we'll leave it as an instance. Let's add another parameter. Let's call it radius, and let's make it instance parameter. Add another parameter. We'll call this one length, and we'll set it to instance also. And we'll add the final parameter, which will be angle elevation. Change the parameter type from a length to angle, and set it to instance. Go ahead and hit OK. Hit apply and hit OK. So now that we have those parameters created, let's go ahead and link up the parameters in family C to the parameters we just created. So finish, let's go ahead and link it up to finish. Radius, let's link that up to radius. And it broke the family, probably because the radius is at 0. So let's go ahead and hit cancel, hit OK. Let's go back to our family types, and yes, radius is 0. So let's set that at 3 inches. Let's set the length to 12 inches. Let's go ahead and hit OK. Hopefully it doesn't break the family again. So again, let's link up radius to radius. Let's link up length to length. Let's link up angle to angle elevation. Go ahead and hit OK. And as you can see, the dimensions did change for family C. But just to verify, let's flex the family. Go ahead and open up the family types window, and let's save the project. So let's change the radius. Let's change it to 1 feet. And there it grows. Let's zoom back out a bit. Let's open up family types again. Let's change the radius to 1 inch. Let's change it to 5 inches. Okay, so that works. Now it's time for the length. Let's change the length to 13 feet. Again, it went out the window, so let's go ahead and zoom out a bit. And let's open up the family types again. Let's change the length to 4 feet. Let's change it to 8 feet. That works. Now let's change the angle elevation, since we have the front view visible here. Let's change it to 45 degrees. Let's change that to 90. Let's change that to 135. Let's go to 180. Let's go to 215. Let's go to 270. Let's go to 315. And let's go to 360. So it seems to be working out so far. Let's go to 0. And for now we'll leave it to 0. So now I'll move the family types window over, and since we have plan view still open here, I'll go ahead and close it out and zoom out plan view for a bit. So now that we're out here, let's open up the family types again, and let's change the angle of angle top. So it's at 45 right now. Let's go to 0. Let's go to 45. Let's go to 90. Let's go to 135. Let's go to 180. Let's go to 215, 270, 315, and 360. And again, it breaks the family because the parameter actual host top is set to the value of 540 degrees. So we want to test 360, and let's change it to 0. And this is basically family B. So here we found out that we can rotate an object 360 degrees in plan and elevation view. And since we're still testing the family, let's go ahead and test it with different values. Since we have the front view tested and it worked, let's try the right view. Now for the right view, let's go ahead and change the angle top to 90 degrees. And let's head to the right view. So go ahead and right click the right view, open, and let's maximize this window here. Let's go ahead and click on the reference level and move it away. Move it here. Go ahead and open up the family types, and let's change the radius to 1 inch. Let's change the length to 12 inches. Go ahead and hit OK. And let's open the family types again. So here, let's go ahead and flex the family. So the angle elevation is at 0 right now. Let's go ahead and change that to 45. There it is, going 45 degrees. Let's go to 90. Let's go to 135. Let's go to 180. Let's move it over. Let's go to 215. Let's go to 270. Let's go to 315. Move it over. Let's go to 360. And that's pretty much it for right view. But let's say our angle in the floor plan. Let's open up the floor plan. Let's say the angle is not 90. Say it's 45 degrees. And go ahead and hit OK. And let's say in front view, we want our angle to be, let's say we want it to be 75 degrees. Now let's go ahead and measure up that angle. And is it 75 degrees? No, it's not. It's at 79.270 degrees. So what's going on here? What's going on is that, let's go back to plan view. What's going on is that front view is basically here. I'll draw a reference line to represent front view. Front view is basically here. And front view is looking this way. And as you can see here, the angle between front view and family C, it's not perpendicular to each other. The reason why we can get it, the reason why it's looking funny right now is because front view is not looking directly It is looking directly at family C, but family C is not, it's being obscured from the angle we placed, from the angle value that we put down, since it's at 45 degrees. One way to verify that the angle elevation is 75 degrees is to create a section view. So I'll go ahead and delete this. And it's to create a section view that runs parallel with family C. So I'll go ahead and just draw a section view here. And since it's going at 45 degrees, I'll make it run parallel to it. I'll set this to 45 degrees also. So go ahead and click on the section view, right click it, and click on Go to View. And here, let's go ahead and measure out the angle to see if it does equal 75 degrees. Let's go ahead and click the visual style of wireframe. And let's go ahead and click on the reference plane to family C. And here it comes up to 75 degrees. And if we go ahead back to family types, let's say we want it down 35 degrees. And you can see here it goes down 35 degrees. So let's go back to reference level, and that's just a point I want to make out that, you know, if you do set the angle that's not parallel to the view, then it might be off of what you put down. And this is one way to verify it. And of course, once you place it in a project, you can always verify it by creating a section view parallel to it also. So that pretty much wraps it up for family B. I'll go ahead and delete the section view, and I'll set the values to 40. Let's change the angle top to not 45 degrees, but to 0 degrees, and the angle elevation to 45. And this is just to prepare for family A. One thing I'll also do is I'll go to 3D view, open it up, and just select everything that I can. And I'll hit the filter button down here, and I'll go ahead and hit check none and click on the reference lines. The reference lines, I want to change the reference to not a reference. This will make sure that when the family gets nested into a project or another family, then when you're online and locking, you won't hit the reference line when you align and lock. The reason is because the reference lines in this family, it's being rotated, so you will want to hit a reference plane that's static instead of moving around and rotating like the reference planes are in this case. So this is it for family B. Let's go ahead and save it and move on to family A. Before we go to family A, I'll give you a brief history about family A. Family A shows an application theory of what we did in family B. I used it to show the supports on a commercial water slide, and this is actually where I first thought about rotating an object in top and elevation view, because the CAD drawings that was given to us show the support pose at an angle in top and elevation view. And of course I wondered how can I replicate this in Revit? How can I rotate an object at any angle in top view and elevation view? So that's where I began. And since family A is essentially a support family, I'll show you how to make one yourself. But first, I'll show you the commercial water slide we did. So here's a generic water slide we did as a test project for our client. So as you can see here, this is basically the support for the water slide. And as you can see, the poles are at various angles and top and elevation. But let's go to that second level, and let's go to south view. I'll go ahead and tile out the views, and I'll minimize 3D view. So I'll zoom in a bit, and I'll show you what I mean. So in plan view, let's focus on this pole right here. So right here, it's at an angle right now, and if we go to front view, here it is again at an angle. And that's essentially what showed up in the CAD drawings, and that's what I thought about replicating in the first place, which kind of drove me insane for a couple hours there, but I eventually figured out how to rotate the family. But anyway, that's just one example of how you can use family B to rotate an element any way you want. So let's get to family A. Go ahead and close this out. This is family B. I'll keep it open for now. Let's close out the slide. So for family A, so let's go ahead and open up a new family, and we'll set it to generic model. So for family A, I'm gonna do things a little bit differently here. It's gonna be a lot more detailed and technical components put into here, because this is how I model, and since we're going to be placing a lot of instances of family B, I would like you to also organize your family out, just in case you get lost in the process. And once you start mapping things out in your Revit family, in the future, if you look back into the family, you will have it mapped out, and you can still track back what you did. So what do I mean by that? I mean, for the case of family C and B, I haven't been naming the reference planes. Naming the reference planes in family A will be important because there will be multiple instances of family B placed around, and they will be locked into their own reference planes. And since family B, if a family B gets placed 4 times, there's going to be 4 instances of family B lying around. And since they'll be lying around, they'll be aligned to their own reference planes, and if we don't name them in a organizing structure, then later on in the process we can get lost, and that's where a lot of frustration can build up. But anyway, let's get on with family A. First thing we'll do is we'll save the family, and we'll name it A. So before we nest in family C, let's build up all the components we need before we nest in family C. So first thing we do is we'll draw the main support pole, which family B will be looking like it's extruding out from. So this is just a simple pole. So first thing we do is we'll draw 2 vertical reference planes and 2 horizontal reference planes, and we'll leave these original reference planes here in between the reference planes that we create. So let's go ahead, draw a reference plane. Let's go to create reference plane, and let's draw the vertical ones first. And it doesn't matter what the distance is between them. And let's draw the horizontal reference planes. And before we do anything to the reference planes, let's go ahead and name them. As you can see, these two reference planes here, they are already named, and they have the is references already defined. So over here, this one's center left right, and this one is center front back, as you can see here. So let's go ahead and select this vertical reference plane here. Let's go to the name, and we'll call it left. Let's set the is reference to left. For this, let's select the other vertical reference plane. We'll name it right. And we'll also set the is reference to right. Now for the horizontal reference planes, let's select this one. Let's call it back. And set the is reference to back. For the other horizontal reference plane, we'll call it front. And we'll change the is reference to front. So now that we have these reference planes named and the is references set, let's go ahead and create some dimensions on them so we can flex them around. So go ahead and activate the Align Dimension tool. Let's create an equal dimension between the vertical reference planes. So go ahead and select all three reference planes. Set the dimension here. Go ahead and hit the equal button. And let's create one more dimension from the center reference plane to the left. And let's name the let's give the dimension a label, and let's call it radius. Go ahead and hit OK. Let's create more dimensions, and we do the same thing for the horizontal ones. Go ahead, select all the reference planes, hit the equal button, and create a dimension from the center to the back. And again, let's label that dimension radius. So now that we have these reference planes and dimensions set up, let's go ahead and flex the family. So here it's at 2 feet. Let's change it to 8 feet. Let's see if both dimensions flex. And it looks like they do. It looks like the reference planes wasn't long enough for it, but it looks like it's working well. Just in case, let's bring it out to 1 feet. So here it looks like it's working out well also. Looks like it's 1 feet between each reference plane and they're equal to each other. So since that works out in in top view, let's go ahead and go to front view. Let's open it up. First thing we do here is we'll move the reference level away from the reference plane, just in case we accidentally align elements to it. So first thing we do here is we'll draw a reference plane. Go ahead and draw a horizontal reference plane. Let's draw it somewhere up here, and it doesn't matter the distance between each reference plane, it's okay. Go ahead and select this reference plane down here. Let's go ahead and pin it. The shortcut for pin is to press PP, or you can just go up here, click on the pin. So now that this reference plane is pinned, let's go ahead and name it. We'll name it bottom. And we'll set the is reference to bottom also. And for this reference plane we created up here, let's go ahead and name it top. And we'll also set the is reference to top. So now that we have that set up, let's go ahead and create a align dimension between the between the bottom and the top. Go ahead, select the dimension, and let's give it a parameter name. Let's call it height. Go ahead and hit OK. And let's go ahead and test out height to see if it works out. Now, since the reference plane bottom is pinned, when the height flexes, this reference plane should not move, and if it does, then we have a problem there. But let's go ahead and test it out. Go ahead and open up the family types window, and let's change the height. Let's say 10 feet. Let's say 1 feet. As you can see, it's moving to 1 feet. Let's go 7 feet, and bring it down to 6 feet for now. So now that we have the basic skeleton set up for the main support, let's go ahead and hit OK, and let's go ahead and go to reference level and draw in the geometry. Here I'll just be using a extrusion here, and I'll just be drawing an arc. Go ahead and hit the arc. Make sure you select the start, end, radius, arc tool. There's different arcs you can create here, but this is the one we want. Go ahead and select it, and select the starting point at the center, front, back, and the left reference plane, and select the other intersection on the opposite side. And here our arc, go ahead and hit the center left, right, and the reference plane back. Now let's go ahead and align and lock. Let's align and lock this endpoint to these two reference planes, and this endpoint to these two reference planes here. So let's go ahead and align and lock them. And for the other half of the circle, I'll just go ahead and mirror the arc there. And if you want to know the shortcut for mirror, it's just MM. And let's go ahead and hit this center front back reference plane, and it mirrors. And that's basically it for our extrusion. So let's go ahead and hit finish, and let's try to pull it apart, see if we can, just in case the constraints in the sketch did not work. So in this case, it's looking like it is, and that's good. So let's go to front view and let's open it up. And as you can see here, if you select the extrusion, you can stretch it up and down if you want. But here in this case, I want the extrusion to be following the height from the reference plane bottom to the reference plane top. So let's go ahead and align and lock the extrusion to the reference planes. So let's click on align and select the reference plane top, and select the top of the extrusion. Go ahead and lock it in, and we do the same thing for the bottom. Go ahead and select the bottom reference plane and the bottom. So now that we have the extrusion set up, let's go ahead and test the family again, just to see if the extrusion follows. So first thing we'll do is we'll test the height out, and let's open up the family types window. So it's at 6 feet right now. Let's change it to 1 feet. Let's change it to 3 feet. Let's change it to 5 feet. Let's change the radius to 3 inches. So it looks like the radius changed with it too, and that's good. Let's change the height to 9 feet. And look, it's looking like the height's working out so far. But let's see about the radius. Let's go back to plan view, where we can see the whole circle here. So go ahead and open up the family types window, and let's change the radius to 1 feet. Looks like it's flexing well. Let's change it to 6 inches. Let's change it to 2 inches. And we'll leave it at 6 inches for now. So now that we have the main support drawn, let's go ahead and nest in family B. So I'll go ahead and close all the hidden windows and open up family B, which I still have open. And you can go ahead and nest in your family B also. Go ahead and click load into project. And for now, we won't place family B in yet. We still want to set up the reference planes and parameters first. So first thing is we'll add parameters. Let's go ahead and open up the family types window. And we'll add in, well, actually be adding a lot of parameters for each instance of family B we'll be placing. For this exercise, I'll be placing in 3 instances of family B. So let's go ahead and start putting our parameters. So let's go with the first one. We'll call it support 1 height. And I'll go ahead and highlight support 1, since support 1 will have multiple dimensions. And it's easier if I just copy and paste. And it will be a length. Change the group from dimensions to constraints and set it to be an instance parameter. Let's now go to the next reference, the next parameter. We'll call it support 1 length. Change the group to constraints, set it to instance. Next one will be support 1 angle top. The type of parameter, let's change it to angle. Let's change the group to constraints and we'll set it to instance. Next one will be support 1 angle elevation. Change the type to angle, change the group to constraints, change it to instance. And that's basically all the parameters we need for one instance of family B. So I'll go ahead and replicate this 3 times. This will be a total of 16 parameters. So I'll go ahead and name it support 2. I'll go ahead and copy it. There's length, constraints, instance, change it to constraints. There's height, constraints, instance. There's angle top, change it to angle, set it to constraints, instance. Next one is angle elevation, change it to angle, set it to constraints, set it to instance. And that's it for support 2. Let's move on to support 3. And copy that. So again, start off length, change it to constraints, set it to instance. Next one will be height. Oops. Change it to constraints, set it to instance. Next one will be angle top. Let's change that to angle, move it to constraints, set it to instance. Next one will be angle elevation. Change that to angle, move it to constraints, set it to instance. So there we have it. That should be all the parameters we need for each instance of support we're going to make. Let's go ahead and hit apply and hit OK. And now let's go to front view. Let's go ahead and open it up again. And let's draw in 3 more reference planes, 3 more horizontal reference planes. So go ahead and draw 3 horizontal reference planes, and it doesn't matter where they are. Now I like to make them shorter than the reference planes I already made. It's just for looks, and it makes it look more organized later on when I'm done with the drawing. So I'll go ahead and draw 2 more. Oh, let's go back to family types and add 1 more parameter called finish, which we forgot to make. Let's change it to material. And we'll set it to type. We'll leave it at type. So back to the reference planes we made here. Let's go ahead and name them. Let's name this one support 1 dash left parenthesis center. Actually no, let's call it support 1 dash center left parentheses elevation. Close it with a right parentheses. And I'll go ahead and copy the name since it will be repeated 2 more times. I'll expand the window a bit so we can see the whole name. And we'll leave the is reference as a weak reference, just in case when it gets placed into a project, we want to verify the height of each support pole that we'll be making. But you could turn it off if you want to, but for this case, we'll leave it as a weak reference. So again, this reference plane will paste the name, and we'll just replace the 1 with 2. So this is now support 2 center elevation. And for this reference plane, we'll paste the name again. And this one will be called support 3 center elevation. So now that we have a basic setup going on, let's go ahead and draw in some dimensions. Go ahead and click on the align dimension and just create an align dimension from the bottom reference plane to each reference plane we drew. So again here, whoops, guess I create 2 of the same ones, but here it doesn't matter which value they are, since they'll be given a parameter name in a bit. So this one, since this one we labeled support 1, let's go ahead and label that support 1 height, just to keep it organized. And this reference plane support 2, and again let's label it support 2. And this one support 3, let's go ahead and label it support 3 also. And let's go ahead, go to family types, And let's change some values around. So let's change the height to 50 inches. Change support 1 height, which is here. Change that to 10 inches. We'll change support 2 height to 20 inches. Support 3 will go to 40 inches. Go ahead and hit OK. Let's go ahead and change our units to just to fractional inches, since we're not using feet here. So now that we have the height set up for each instance we're going to make, let's go ahead and open up the plan view and let's start placing in family B. So go ahead in your bottom left window, the project browser window, go ahead and expand families, generic models in B. Go ahead and right click it and create an instance. So we'll just place it somewhere around here. Doesn't matter where you place it. And let's go ahead and align and lock it to the reference planes. Let's go ahead and click on the align tool, and we'll lock it to the center front back and the center left right here. So let's go ahead and select the center front back, and we'll align and lock it to this reference plane. Same thing for center left right. Go ahead and click it, and we'll select this reference here, and let's lock that in. Let's open up the front view, open it up, and let's move it down a bit. Go ahead and select family B and move it down just a tad bit so you can see it more. And let's align it and lock it to support 1 center elevation. So we won't be aligned to this reference here. Actually be aligned to where's that reference. And I did not find the reference. So there is something that I did not do in family B that I should have done. There should be, if I hit the align tool again, there should be a reference here that's horizontal with the reference planes here, but it's not showing up. So I'll go ahead and let's open up family B again, and let's figure out what's going on there. Let's open up front view, and let's take a look at this reference plane. And as you can see, it's not set. The is reference is set to not a reference. So that means when I highlight this reference plane in family A, it's not going to show up. So let's change the is reference and let's set it to bottom. Go ahead and hit apply, and let's save it, and let's reload it back into family A. And here we'll just overwrite the existing version. And let's try the align and lock again. So go ahead and select support 1 center elevation. And here we see the center. So let's go ahead and select that reference and let's lock it in. Go ahead and select family B, and let's start linking up the parameters. So let's go ahead and link up finish with finish, radius. The radius we could leave alone. Yeah, let's just leave the radius alone for now, since we didn't set a parameter up for that. Let's align the length to support 1 length. This is going to be our first support, and we'll just repeat it more afterwards. So here, the constraints are not satisfied. It's probably because the parameters are 0 inches, which will break the family. So let's go ahead and open up the family types window, and let's go to support 1 length, and it is at 0 inches. So let's go ahead and set that to 1 feet. We'll also go ahead and set the length for support 2 and support 3 to be 1 feet. It should be 12 inches. So go ahead and hit OK, and let's try it again. Let's link up the length to support 1 length. Let's link up the angle top to support 1 angle top. Let's link up angle elevation to support 1 angle elevation. And of course, since we have our first one set up, let's go ahead and test it. So let's go ahead and test the support 1 height. Let's bring it from 10 inches to 30 inches. It's going up. Go to 18 inches. Let's go to 0 inches. Let's go to 7 inches. Let's go to 10 inches. So it works there. Next thing would change is the length. It's at 12 inches right now. Let's go ahead and hit OK, and we'll draw an aligned dimension from the center left right to the endpoint here, just to see if it measures up when we change the parameter. And of course we'll delete 12 inches once we're done testing the family. So it's at 12 inches, change it to 18 inches, change it to 24, change it to 30, change it to 2 inches, change it to 8 inches, and we'll change it back to 12. So now that we have the length and the height covered, let's try the angle elevation since we have our front view opened up. So let's try 45. Okay, so this is saying that the dimension we placed here, since we started at the center left right, it won't actually read anymore because the dimension we placed there, it's not going to follow family B as it rotates around. So let's go ahead and remove it since we're done testing the length. And as you can see here, it moved 45 degrees. Well, not moved, rotated. So let's change it to 90. Let's change that to 135. Let's change that to 180. Let's change that to 215. Let's change it to 270. Let's go to 315. Let's go to 360. So we can rotate an elevation view 360 degrees. So let's go ahead and leave it at 0 for now. And let's go ahead and hit OK. So let's go ahead and open up our floor plan. And in here we'll test out the angle, the rotation of the angle in top view to see if it flexes here also. So let's start off by selecting the value of support 1 angle top. and let's change it to 45. Let's change it to 90. Let's change it to 135. Let's change it to 180. Let's change it to 225. Let's change it to 270. Let's go to 315 and 360. So this pretty much sums up family A. The only thing left to do is to create 2 more instances of family B and repeat what we just did for our first support that we did. So let's go ahead and do it again 2 more times. So what I'm going to do is, since I have family B still expanded, I'm just going to click on type B here and just drag it out. And I'll just place it over here for now. So first thing I'm going to do is I'm going to align it and lock it to the center front back reference plane. And I'll open up front view to align it like the rest. So second thing I'll do is I'll align it to the support to center elevation reference plane. And then I'll align it lock to the center left right. So let's start linking up the parameters here. Let's link up finish to finish, length to support to length, angle top to support to angle top, angle elevation to support to angle elevation. So let's go ahead and open up our type, the family types window, and let's flex the elevation, the angle elevation of support 2. So here it's at 0. Let's change it to 45. Let's change it to 90. Let's change it to 135. Let's change it to 180. Let's change it to 225. Let's go to 270. Let's go to 315. And let's go to 360. So the angle elevation rotates well and it doesn't break. But let's change the height. Let's go to 0. Let's go to 15. Let's go to 60. And it's all the way up there. So let's close it and zoom out so we can see it. Let's open it back up and let's change the length to 50. Let's change it to 5. Let's change it back to 12. So in elevation view, the angle was able to change, the height was able to change, and the length was able to change. So let's set the height back to 20 for now. And let's go back to our floor plan to see if it rotates in plan view. One thing I want to mention here is since we have 2 of the same instances here, I'm going to go ahead and change the length value of support 2 to 24 inches. Since the support 1 is 12 inches, I want to change the length of our second support to 24 inches. So when it rotates up here, we won't mistaken it for our first support, thinking that the rotation did not work. So I'll go ahead and change to 24 inches. And I'll change the visual style. We can leave a wireframe, it works. So let's go ahead and start flipping it around. So here's our support to angle top parameter. Let's start off with 45. Let's go to 90. Let's go to 135. Let's go to 180. Let's go to 225. Let's go to 270. Let's go to 315. And let's go to 360. So our support 2 was successfully completed. We were able to change the parameters of the length, the height, angle top, and angle elevation. So let's go ahead and set the angle back to 0. Let's change the length back to 12. Let's move on to our third support. So again, drag another instance out. Align it to the center front back reference plane. Open up front view. Let's align the bottom with our support 3 center elevation, and align the log to the center left right reference plane. Now let's select our third instance and link up the parameters. Let's link up finish to finish, length to support 3 length, angle top to support 3 angle top, and then angle elevation to support 3 angle elevation. So once again, let's test out our third instance by flexing its parameters. So let's start by changing the length. Let's go to 68 inches. Let's go to 1 inch. Let's go to 25. Let's go to 47. So that works. For the height, let's start with 0. Let's go to 24 inches. Let's go to 86 inches. It's all the way up there, so let's go see where it's headed. Seems okay. Let's go to 100. And let's bring it back to 40. Let's change our length back to, let's change it to 24. So we don't have to change it when we go to top view. Now it's time to test the angle elevation. So let's start off with 45 degrees. Let's go to 90. Let's go to 135. Let's go to 180. Let's go to 215. Let's go to 270. Let's go to 315. And let's go to 360. So in elevation, the angle elevation, the length, and the height was able to change. So the next thing to do is to open up our floor plan and test out the angle on top. So let's see what happens. So let's go with 45. Let's go to 90. Let's go to 135. Let's go to 180. Let's go to 225. Let's go to 270. Let's go to 315. Let's go to 360. So in here in top view, we're able to change the angle top for our third support. Now, one thing you might ask is, if our first support worked out fine, why do we need to test the other two? It's to make sure that each individual parameter flexes with each individual support, and it's also to make sure that we align and lock each instance to its proper reference plane. And by flexing these parameters individually, we're able to find out if we constrain each instance correctly, and if it breaks or moves in a funny direction. By flexing individually, we'll eventually catch all the mistakes if we made any. Now, it's not a foolproof plan, but it's one that works pretty efficiently for me, and I hope it does for you too. The last thing to flex would be our finished material parameter, which we haven't tested out on any supports yet. So let's go ahead and hit OK, and let's open up our 3D view. So let's go ahead and open up our 3D view. Let's change the visual style to shaded, and let's change our finish parameter. So let's go ahead and close the material editor, and let's change the material to glass. So all three instances, they work. The materials change for each one of them. But let's go ahead and click on the extrusion that we made, and let's do a temporary hidden by pressing HH. And it's just to make sure that on the inside the materials changed as well. So let's go ahead and reshow our extrusion by pressing HR, and let's change the material back to a default material. So there you have it. Here's my little exercise of rotating an object 360 degrees in any view. Now again, you can change the geometry if you want, and the concept to suit your needs to finish up whichever model concept you're trying to create. Now that this exercise is over an hour long, I think it's pretty long. The video itself, it seems too long for something that can be created in 10 minutes or less, which I find pretty astonishing because this is my first few tutorial videos that I did, and creating a tutorial for an exercise that takes about 10 minutes to get done, but it ends up to be over an hour long. It's pretty new for me. I find that pretty amazing. Well, that concludes another video from B3D, and I hope I'll see you next time.